Hello everyone. Today I'm going to talk about AP arithmetic progression. What is it, what we have to learn to understand it, and how to calculate the nth term of an AP and sum, and how the formula is derived. So let's see here a pattern of numbers. There are 5 examples. Can you see any pattern in these numbers? I'm sure most of you can. In the first example, each term is 1 more than the term preceding it. In the second, each term is 30 less than the term preceding it. In the third, each term is obtained by adding 1 to the term preceding it. Likewise, all the terms in the list in the fourth example are 3. So each term is obtained by adding or subtracting 0 to the term preceding it. In the fifth term, likewise, each term is obtained by adding minus 0.5 to the preceding term. So the pattern here is clear. If a certain pattern of numbers occurs where each term is calculated by adding or subtracting difference between the terms, between the succeeding terms, is called arithmetic progression. So now that we have established the definition, the concept of AP arithmetic progression, we now look at the nth term of any progression. So let's consider a situation where you earn $10,000 a year initially. Your company promises to increase your salary by $500 every year. So if you have to find out what your salary would be in the 6th year, using the arithmetic progression is very helpful. So as we can see, in the second year, if we calculate step-by-step process, your annual salary will be plus 500, that is 10,500. In the third year, plus 500, 11,000, and then 11,500, then 12,000, 12,500. So in this step-by-step process, you will gain 12,500. But if we have to calculate more than that, if you have to calculate after 30 years, after 50 years, then step-by-step calculating will be very tedious process. So, but if we see the step-by-step process, we can recognize the pattern here like this: 10,000, 10,500, 11,000. So if you can see that these terms, these patterns are in arithmetic progression. So how can we make the process shorter? Another way of calculating this is this. So salary at 6th year is equal to salary at 5th year plus 500, because each year you are promised to increase your salary by $500. So we can write this like this. In the first year you have 10,000, and at the end of 5th year you are going to have 500 plus 500 plus 500 plus 500, like 4 times 500, and that is the salary at the end of 5th year. Likewise, plus 500 is already there. So what we can see from these expressions, that it simplifies to 10,000 plus 5 times 500, which is 10,000 plus 6 minus 1, 500. So in the 6th year, we'll have 12,500. So in the same process, we got step-by-step process, we got 12,500, and in this way also we got 12,500. So why did we do this problem like this? Because if you see here, we can find a formula here. So if we consider the first term as A and the common difference between succeeding terms as D, then nth term of this arithmetic progression AP can be given by Tn, that is nth term, is equals to A plus n minus 1 times D. Here A represents the first term as already stated, n is the nth term of the AP, and D is the common difference. Likewise, in this example, we can see that A is equals to 10,000, which is the first, which is the salary of the first term, and N is the 6th year, that is the 6th term we have to find out, and D is the common difference between succeeding terms, which is promised that $500 is the common difference. So in this way we can find the formula of nth term of any arithmetic progression, and it is very useful to use this formula. So it is also called general term of AP, this formula. And now we get on to sum of then AP. So let's say you want to calculate the total amount of money you would have earned after 6 years. So how do we do that? So similar to finding the nth term, we can calculate it step by step sum. Like first year is 10,000, second year is first year 10,000 plus second year you earn 10,500, which total adds to 20,500. In the third year similarly we get 31,500. So likewise if we do in this process, it would be very tedious task, especially considering the sum of very large number of numbers. So let's say we have to find the sum of or the total amount of money you earned after 30 years. It will be a very tedious process. So in order to simplify this, what can we do? How can we make this task easier or this process shorter? So similar to nth process, we consider a to be the first term and d as the common difference. So the arithmetic progression seems like this: a plus d, a plus 2d, like this. In the example, it becomes 10,000, 10,000 plus 500, 10,000 plus 2 into 500, that is 11,000, sorry. And we know that nth term, we already calculated, we already found out the formula that nth term is equals to a plus n minus 1 times d. So sum of n terms, that is sum of every year's salary, becomes Sn equals a is the first term, a plus d is the second term, a plus 2d is the third term, like this wise up to nth term, because we have to find the sum up to nth term. So if we add individually the each term up to nth term, we get the sum. That's simple common sense. So we can write this in reverse order as well, because it gives the same sum. Which goes back from a plus n minus 1d to a plus n minus 2d to, in the final, a plus d to plus a. Sorry, this is mistake, plus a. So we can add this and this and this. We get s plus s equals 2s on adding these two term wise. Then a plus n minus 1d adds up to 2a plus n minus 1d. Likewise, a plus d plus a plus n minus 2d adds to 2a plus n minus 1d. So similarly, if we add each term wise, term by term, then we get 2a plus n minus 1d, 2a plus n minus 1d up to the very last term. That is, we get 2a plus n minus 1d nth times. So it simplifies to 2s equals n times, this is n times 2a plus n minus 1d, since there are n terms. So we finally get the sum expression, that is s equals n by 2, 2a plus n minus 1d. So this is the way the sum formula came to be. So in this way you can calculate any sum of any number of terms of any arithmetic progression, and hope this video helped. Thank you.